Okay, so I'm here, right here. Oops, we're at page, I don't know, this is 6.2, properties of parallelogram. And we actually learned this in class today, but I keep going the wrong way. I just wanted to make sure that I show this to you again, because I think we need it. So this is page 75, okay? So go there. And so what I did today was I gave you a parallelogram, and so what you had to do was you just had to use this and also maybe share one with a partner and then try and prove the four properties that we learned. So first thing, they were two exactly same parallelograms, right? So what you did was you measured this side and then they measured the same, as you can see. And then what you did was you went over here and you put it on top of each other and they measured the same. And that's how you kind of prove that this side and that side measure the same, right? Same thing with the top part. You went like this and yeah, they measure the same. And then so now you wanted to see if this bottom part, which is the same as this side, was the same length as the bottom part, right? So all you did was bring it down and yep, it went right on top of each other. So you knew that, you know, the two opposite sides right here on top and at the bottom, they measure the same. So you figured that out. And that was really great. That was one of the properties, right? So that would be this one right here. Opposite sides are congruent. Ooh, I don't know if I can do this really well. Okay, there you go. Opposite sides are congruent. The next thing that I wanted to do was move on to the other three things, right? Okay, opposite angles are congruent. So then what you guys did was you had the parallelogram, and some of you did it like this, okay? So you put the two parallelograms on top of each other because they were exactly the same size, and then you said, hey, look, this angle here and this angle here, they measure the same because, you know, they're like right on top of each other. And then what you did to prove that this angle and this angle is the same was, you see the one in the back? You just pulled it out and then you kind of like moved it and put it upside down, okay, and then like kind of put it on top of this one right here. And then you could see that they were the exact same match, right? So that's how you knew, oh, these two opposite angles measure the same. But at the same time, I said something to you. I said, we already know that this is a parallelogram, so if you were to continue to draw the lines, uh-oh, I can't do this. Okay, there you go. And so I stuck it right here, and if you were to continue on with the lines, and these would be your two set of parallel lines, and then your transversal was here, okay, this one was your transversal, then I asked you, what is the relationship between this angle here and that angle? Because they're supposed to be the same, but how can we prove it, right? And that's what I asked you. And you said, okay, I don't know, we cut it out, and that's fine. But anyhow, look, this angle and this angle are corresponding angles because they're both on the right-hand side of the transversal, which is this line right here, and they're both on top, right? So they measure the same. And then, now if I were to turn the parallelogram this way, now we have this line, and they are parallel to each other. And now this time, my transversal is going to be this one, okay? So now I asked you, what's the relationship between this angle right here and this angle right here? And again, you said that, you know, they are corresponding angles, and so they measure the same. Then finally, I said, I asked you, what's the relationship between this angle here and this angle here, right? And you said they are vertical angles, okay, vertical angles. And so they measure the same. So therefore, you know that this angle and that angle measure the same, right? So anyhow, these two are opposite angles, they measure the same. And then these two are opposite angles, and they measure the same. So that was the second property, right? So then now let's see, what was the third thing? We also had to know that these two angles, when you add them together, this one and this one, the x and the round one, they add up to be 180 degrees, okay? And I said you can prove it because if these two are parallel lines and this was the transversals, these two would be same side interior angles, and they are supplementary anyway, right? Okay, so that's how you know. Same thing over here. Okay, so when you add these two up, or these two up, they're always going to be 180 degrees. Finally, the diagonals, they always bisect each other. So there you go. I am connecting the two diagonals right now. It's difficult, but I folded it, right? There you go. So just so you can see, let me connect it. Okay, there you go. So I have one diagonal. So then you can see that this triangle here on top and this triangle at the bottom, they are congruent to each other. Okay? Because this side and this side measure the same, and this side and that side measure the same, and this is just one line that measure the same. So this triangle and this triangle, they are exactly the same, okay? Alright. But then, if I were to fold it like this, the other way, and draw the other diagonal, okay? So you can see the green line, okay? It's the same thing. If I were to fold it like that, okay, you would see that this triangle on top and this triangle at the bottom is the same, okay? What that leads me to believe is that you see the top triangle on top and then the bottom triangle, okay? Those two measure the same. You know why? Those are congruent to each other. You know why? Because this side on top and this side at the bottom is the same, right? And then this side and this side has to be the same, okay? And this side has to be the same. No, that was really silly. It's because this side is the same, and then the angle, because remember, this angle and that angle has to be the same because this big two triangles were the same. Okay, I screwed up.